GCF, the greatest common factor, does it have one? No, other than 1. So then that wouldn't change anything. And then what would we do next?
Multiply the 6 and
Right. So that would give us negative 24. And then we need factors of negative 24.
6
2 in. And then this one is. So I didn't put the negative in there. We have to figure out which pair would work. So then we're multiplying to get negative 24. We have to add to get negative 5. Which one would work? Which pair would work? 8 and 3, which one would be the negative? Would 8 minus 3 give us negative 5? Negative 8, there we go. And then what do we do with those?
You would do 6y, so that's minus 8 plus 3 minus 4.
And really it didn't matter if you wanted to put the if you wanted to put the 3 first, because 6 and 3, you could divide a 3 out, you could do that also, it doesn't matter. Okay, and then split it where?
In the middle.
So right here?
No.
Right here? Okay. And then?
You find the ones that go in each other. Like
So both of these?
2y.
Okay, so the GCF for both of these, which would be 2y. Divide that out, and what's left?
2y.
And then we do the same thing for the other side, but what would that GCF be? 1. Leaving us with the same, 3y minus 4. And then our final step?
Oh wait, no, you too. 2y, 1, and then
3y. Do not really combine them, but we write down the factors. Yes, we write down the final factors. The more you get the hang of this, the easier this becomes. But you have to practice this, because if you're not practicing this, you will lose it. Alright, let's do example 4. Does that have a GCF? No, other than 1. And then if we multiply 12 and negative 5, negative 60. What are some factors of, put negative 16 with 60? I heard 6 and 10. 1 and 60. 5 and 12. What else? 30 and 2, 4 and 15. 1 more. We have 1, we have 2, we have 4, 5, 6. What about 3? 23. Okay, so which of those would multiply to get negative 60 but add to be positive 11? 4 and 15. Which one would be the negative? 4. Alright, rewrite that. 12c squared. I'm going to put the 15 first, but it doesn't matter. Plus 15c minus 4c plus 5 minus 5. And split that down the middle. If you put 4 first, go with your GCF. If you did this like mine, then go with mine. What would these two have in common?
C.
C and
Three.
3. Right? We divide that out. What's left?
4
Plus 5. What did we divide out of the last two?
1.
Positive 1? Negative 1. To get us that positive 4C plus 5. And then our final two factors? Minus 1 and 4C plus 1. Okay. For the next 9 problems, I'm going to give each table their own problem. They're going to do it. Everyone has 5 minutes to do it. And then we're going to start with the answers, go over any that need to, and then go on to the next part. So pay attention. You guys are number 1. You guys are number 2, 3, 4, 5, 6, 7, 8, 9. Do that problem. You have 5 minutes to do it, and then we'll go over the answers. You guys can talk to each other, work with each other at your group. I'm going to have this table come this way a little bit so I'm not running with you guys. And then you guys will just tell me your answers and we'll go on from there. And then everyone just look at this board until I get the board fixed because I broke it. So if you want, you can come this way. And move it this way. Okay, you can say that. Start with number 1. What do we get answer-wise for number 1? Not here. There's someone from this table. It's okay if it's not right. What'd you get? Okay, so one of them x plus 5 minus 5. Did you get the other part? Okay. You were working on that one. What did you get? 4x plus 5. This. Okay. Did you guys have questions about that one? And this one, if we multiplied these two, we got negative, there wasn't a GCF other than 1. If we multiplied this, we got negative 20. And then the factors of that were 1 and 20, 2 and 10, 4 and 5. To get negative 19, we'd have to do 1 and 20. And it would be negative 20. So this would be 4x squared minus 20x plus x minus 5. And then from this, I could factor out 4x, leaving x minus 5. And then on this side, I could factor out just 1, leaving x minus 5, which would give you your two factors. Right? Table 2, what were your answers?
3a plus
And
2a plus 1.
do you guys have any questions there? So I would be writing these answers down. That way you can go back and rework these problems at a later time. Table 3, what did you guys get?
4y minus 1.
4y minus 1 and
2y plus 3.
2y plus 3. Do you both get the same thing? Do you have any questions? Say that one more time.
Like, I can only see the screen.
I don't know if that's better or worse. Can you see from there? You can also move. So make sure you have those down, and then I'll go on to the next page. Alright, I can't touch this one. This is okay. Alright, group 4.
Negative 2w plus w.
I'm going to say something there isn't right. Because we shouldn't have 2 W's. Allison, where'd you go?
I got 3y plus 1.
For the W's?
I mean, yeah, w.
3W plus 1?
Yeah.
Okay. And
Then I got 5w minus 10.
minus
10.
Kai, did you get either of those? Okay, so let's rework this one. Right. If we look for GCF, it was 1. When we multiplied those, we got negative 30. And then factors of negative 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. And then of those factors, which ones add to be negative 1? This pair, if the 6 is negative. So 3 w squared, let's say minus 6w. That was weird. Plus 5w minus 10. GCF of the first two, 3w, leaving w minus 2. GCF of the last two, 5. Oops, wrong way. Leaving w minus 2. So our factors should be w minus 2 and 3w plus 5. Did you guys find where you made mistakes? Okay. Number 5, group 5.
2p minus 1 and 5p plus 2.
5p, what was that last page?
Plus 2.
Did you all get the same thing?
Yeah.
Yes. Did you have any questions? Okay. Group 6.
We got 3x plus 5, 3x minus 2.
You all get the same thing? Have any questions about that? Okay. Group 7.
2a minus 2a minus.
So if you get something like this, you could also write it as 2a minus 1 squared, but either or doesn't matter. Did we have questions about that one? Okay, group 8. X plus 9. You all get the same thing? Do we have any questions there? Okay, and then group 9.
Oh, we got 3x minus 4 and 2x plus 3.
2x plus 3.
Yeah.
Did you all get the same thing? Do we have any questions there? Okay. So have the answer so that you can go back and practice later, do the other ones. To the best of my ability, we're going to try some of these lower ones. So this just as an extra step. All of these and the ones from yesterday and the ones we started off with didn't have a GCF, or it had a GCF, it was 1. These ones below will have a GCF. I don't know if this is actually recording the screen or just my voice, so I'll add these pictures up there too. That's not what I meant to do. So we'll just do a few of these. So let's start with number 10. If I'm looking for a GCF of number 10, what might those all have in common? Four. If you're not sure, think of the factors of each. Maybe you don't know all the factors of 52. Maybe you know it's 2. But you could find the factors of 20, find the factors of 24. Pick maybe a higher one. Well, you know 5 is not going to work, but 4 might, and start dividing each of these by 4, and if they all give you whole numbers, then that would work. So the GCF is 4. So we're going to divide each of these by 4 and see what's left. What would be left? Minus 13n minus 6. After you factor out that GCF, all the rest of the steps are the same. So then everything we were just doing, we're just going to do again. Multiply 5 and negative 6. Find factors of negative 30. I'm just writing them all out. 10, 5, 6. And then we're looking for which of those would add or subtract to be negative 13. So I heard 2 and 15. Which one will be the negative? So negative 2 plus 15 will give us negative 13. Negative 15. And then we just have to keep bringing down the GCF. So keep bringing down that 4 and keep doing the rest of your steps. So 5n squared, I'm going to put 15 with this, minus 15n plus 2n minus 6. Split that down the middle. I can change colors, I just don't know how. Which one?
The one that you're on.
Oh, okay. I don't use those often, clearly. What is our GCF of this part? 5n. So keep bringing down that 4 from the original. So we have 5n for this part of the GCF. What's left? N minus 3. What could we divide out of the last 2?
2.
Positive 2. What would be left? So then when we write this out, bring down that GCF again. Your outside terms, 5n plus 2, and your inside terms, n minus 3. My handwriting is even worse on this board, so I apologize. Questions on that? You just, yep. If you took it away, you'd have a different problem at the end. Like if you were to graph this, I'll show you guys later how to graph these to find your answer. You wouldn't get the same thing if you left off that GCF. So yes, after you divide it out, you just keep bringing it down. It's really a nuisance. However, if you, I'm not going to show this up here because I don't have space. Let's say you didn't do this at the beginning. You didn't find the GCF. You could still do the rest, but you're going to end up with some huge number, whatever 20 times 24 is. And then you'd have to do everything with that, which can be done, but you're going to have to find the factors of some huge number. So if you start multiplying and you get some big number, there's probably a GCF. Let's do a smaller one. Let's do 12. What is the GCF in 12, or is there one? 2. And then if we divide everything by 2, we have 6x squared plus x minus 1. And then multiply 6 and negative 1. What would that give us? And factors of negative 6 are 1 and 6, 2 and 3. And then if we're multiplying to get a negative 6 but adding to get a positive 1, which factors would work? 2 and 3. Would one of them be negative? Which one would be negative? I thought it would be better over here. It wasn't. Okay. So then we have our original GCF and 6x squared minus 2x plus 3x minus 1. Split that down the middle. Our GCF of these first two would be what? 2x. Leaving 3x minus 1. And then what would our GCF of the last part be? 1. Positive 1. That's supposed to be it. What cancel out? Okay. So we have 2x plus 1 and 3x minus 1 as our factors. Somewhere where you have space, maybe on the sides of the front, or get a separate sheet of paper, I want you to write, we'll just do one of these, maybe we'll do some of these as a warm-up for tomorrow. Just write down that first one, x squared plus 2/3 x plus 1/9. And this will be the last one we do today. Okay, so when you see something like this, you have to rewrite it so that it looks like the trinomials that we're used to. How we would do that is whatever this denominator is, multiply that to everything. So we're going to multiply this entire thing by 9. And when we do that, we get 9x squared plus, what would 9 times 2/3 be? 6x. And then 9 times 1/9 would just give us 1. So now it looks like a trinomial that we're used to.
Wait, so what if you like multiply the 9 to, let's say it's another number and it gives you a decimal?
So in this case, it shouldn't. It should give you some whole number. Right. Then you could work this out just like normal. We'll do that really quickly and then I'll show you how the answer could look. So 9 times 1 would be 9. Factors of 9, 1 and 9, 3 and 3. Which ones would add to be 6? 3 and 3. So 9x squared plus 3x plus 3x plus 1. Split it down the middle. 3x is our GCF of the first two. I'm going really fast because we're running out of time, so I apologize. If this doesn't make sense, and we'll do some more tomorrow as like a warm-up, just come to me. But we'd have 3x plus 1, and then 1, leaving 3x plus 1. So our two factors would be, I'm just going to put that squared, it would be 2 of them, but squared. What you could have also done, now this is a shortcut way, really quickly, if you see something like this and you're thinking, what two numbers would multiply to be 1/9 but add to be 2/3? That would be 1/3 and 1/3. If I multiply these two, I get 1/9. If I add them, I get 2/3. If I started with this, focus really quickly before we still have a little bit of time. And you started off with these factors. While this is not technically wrong, you won't see it like this. So you would have to rewrite this. Set it equal to 0. Solve for x. But then you kind of put it back because you want this to be equal to 0 at the end, so I could multiply both sides by 3. And then if I want this to be 0, add 1 to the other side. This is different. And notice that that's the factor we got. So you could do this, but then you'd have to get the work in between. You'd be missing all the in-between steps and work. So just keep that in mind. There is a Delta Math on A doesn't equal 1 that's due on Friday, as well as a mixed factoring that's everything that's also due on Friday. Come see me after school today, tomorrow, for retake work, finishing tests, if you need help with this stuff, Delta Math, and Thursday as well. You guys can put calculators up.